On and on and on and on. Okay, so a couple of announcements. One, I have scheduled a review session. I meant to post it on the webpage. It's not there, but it will be there. The review session is scheduled for Tuesday at 4:15. I didn't hear a big collective, oh, that's good. In ALS 4001. And yes, I will videotape it. And so bring your questions as always. Tuesday at 4:15. Okay? There is a seminar in there that goes until about 4, so I decided to just make it 4:15 to make it easier to deal with. Okay? Second is, if you have not gotten a note card from me, you have to get a note card from me, so come by my office. I will give you one. For the final, you're required to have a note card from me, even if you don't want to use one. You have to have a note card from me. So please, if you haven't gotten one, come by my office. I'll give you one. If you don't have a note card from me, you will lose points on the final. So it's important that you have a note card from me. Okay? You will have to turn the note cards in when you're done. And that always causes people problems because, oh, I spent so much time working on it, I don't want to turn it in, et cetera, et cetera. And the reason I do that is that I think that you benefit tremendously from doing the note card yourself. And if I don't collect the note cards and make you turn one in, then you give it to your friends and they don't get that benefit from doing it. So if you're really attached to your note card, photocopy it, do whatever you want to with it, but you will have to turn the card into me. Okay? And you'll be doing your friends a favor, obviously, by the fact that you have to do it. By the fact they will have to do it. You're not passing it on to them. But if you don't turn a note card into me, you will lose points on the final. So make sure that you do that. Okay? All right. And I don't do that to be mean. I do it, as I said, so that the people in the future will benefit from those note cards. Yes, question? You can use both sides. You can write on the edge if you can write that tiny. The only requirement on the note cards is it has to be handwritten and it has to be from me. Okay? So are we clear on that? If you bring in a printed note card from a printer, I will take it from you. You can't use that. So you have to have a handwritten note card from me. And again, the same reason being, writing it down really helps you. Okay? So those are important things. Okay, well, we've got a lot of ground to cover today, so we need to get getting in it and going on. So I promised you 3 surprises today. The first surprise is the fact, and that's not too big of a surprise, I've written you some new songs. So every term for my class, I write new songs, and on the last day of class, they get performed. And so I've got a couple of new songs for you today. So brand new things nobody's ever heard before, except my wife. You guys will be famous. You'll say, I heard that song the first time it was ever sung before it went out and sold 1 million. Or before they hauled Ahern away to the nut house, one or the other. All right. So last time I talked about purine metabolism, and I pointed out that importance of balance and regulation. Okay? So that same thing will hold true for pyrimidines. But before I talk about pyrimidines, I just want to touch up a couple of things in purine metabolism. So one of them I've already talked about, and that was the fact that the breakdown of purines leads to uric acid. And I've mentioned that to you. I haven't shown that to you. The catabolism of purines, pretty complicated, blah, blah, blah. But the important thing for our purposes comes right about here. Xanthine is a breakdown product of purine nucleotides. And if we take xanthine, so we see this big scheme up here. These things lead this direction to xanthine and this direction to xanthine. They converge right here on xanthine. Xanthine can be oxidized to uric acid, and that's the stuff that I said caused gout. That's the stuff that Dalmatians excrete, and as a consequence, they have relatively high concentrations of. So we get uric acid and things like gout coming from the breakdown of purines. Okay? Now, purine metabolism is not a trivial thing, although it would seem in some cases like what I'm going to show you in a second would seem fairly trivial, but it's not. So this pathway that I'm showing you on the screen, it's not one that you need to know, but I pointed out to you because it is a fairly minor component of purine metabolism. So I need to tell you a little bit about that. When we make nucleotides, we make them in 2 ways. We make them by a process that's called de novo, meaning starting from scratch. So we can make nucleotides from scratch. That's those simple things that I showed you before. Amino acids, some carbon dioxide, some ammonia, and bingo, we've got the bases that make up the nucleotides. Okay? Well, the other way that we make up those nucleotides is by what's called salvage. And salvage is, as its name would suggest, using pre-existing pieces. So if you, for example, have an old car and the starter goes bad, you can either buy a brand new starter, or you can go to the salvage yard and pick up a starter that has been used, but that you get for a much cheaper price. Well, cells do the same thing with nucleotides. They might have bases floating around, or sugars floating around, or something that they need that they don't want to have to start from scratch. So they use a pathway called salvage, where they're taking these pieces and using them to make nucleotides. The advantage to the cell is that they're, of course, not spending all the energy that it would otherwise take to make those nucleotides. Okay? So that's very cool. Well, as I said, it's not a major pathway. It's a relatively minor pathway. But there's a critical enzyme called HGPRT, which stands for hypoxanthine guanine ribosyl transferase, blah, 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 long name. HGPRT is an enzyme that's implicated in a very odd genetic disease. Okay? A very odd genetic disease. So HGPRT is an enzyme in salvage, and the genetic disease it's involved with is called Lesch-Nyhan syndrome. L-E-S-C-H, its first word, and the second name is Nyhan, N-Y-H-A-N. Lesch-Nyhan syndrome, people who have that disease are lacking this enzyme. They can't do this salvage synthesis that I'm showing you here. Now, you might think, well, they'll just be put out a little bit, but it turns out that it manifests itself in a bizarre behavioral phenotype. People who have this disease chew their lips off. Yeah. The class, I always like the expression of people's faces when I tell them that. It's true. They will literally chew their fingers, they will chew their lips off. And so they actually have to be physically restrained because they will push in and they will do this and they will eat a hole in their mouth. Yeah. Absolutely bizarre. The brain is a very, very odd thing. And so there's some deficiency that's linked to the lack of this purine salvage pathway in the brain that leads to this neurological disorder. Yes, sir? If they have it, period. Yeah. So it'll start out as children. Yeah. Yes, ma'am? Yeah, L-E-S-C-H is two names. And the second name is Nyhan, N-Y-H-A-N. Yes, sir? Is there a treatment for it? Like any genetic disease, essentially no, unfortunately. So it's an oddball. But it's one of the most bizarre sorts of neurological diseases that you ever come across. And I've seen pictures. It's really gross. But people will eat a hole in their mouth because the skin just tastes so good or something. It's very strange. Yes? Making nucleotides from scratch is called de novo. D-E, it's Latin, N-O-V-O. Okay, de novo. Okay, so nucleotide metabolism is important. If we screw it up, we make mutations. If we can't salvage, we can have, in this case, Lesch-Nyhan syndrome. Pyrimidine metabolism is also very important to regulate. Pyrimidines, of course, include UTP, CTP, and TTP. The purines, of course, were ATP and GTP. Now, with pyrimidines, we've got a long, convoluted pathway. Both the pathways have about 10 steps starting from scratch. And no, we're not going to go through and do those pathways. But you've already seen a part of this pathway. Anybody know the part of the pathway that you've seen? Anybody remember? The enzyme that we talked about that was regulated by feedback inhibition? ATCase, very good. ATCase catalyzes one of the earliest steps. It actually catalyzes this step right here. And ATCase, you may recall, was feedback inhibited, meaning that an enzyme that is, a product of the pathway, which turns out to be CTP, this isn't the end point right here, when CTP, which is a few steps down, starts accumulating, it feeds back and inhibits this enzyme. So CTP, if there's too much CTP, it stops the synthesis of the pyrimidine, entire pyrimidine pathway. It's because of this we don't accumulate too much in the way of pyrimidines. Remember also that if we had a lot of ATP, it turned the enzyme on. So if we had more ATP than CTP, the message to the cell is we've got too many purines, not enough pyrimidines, and pyrimidines start to be made. So balance is achieved through ATCase. So with ATCase, we balance the relative amounts of purines and pyrimidines. Okay. And let's see, what else did I want to say there? No. Oh, actually, I will tell you this. So all the pathways that we've seen get us to the monophosphates. When I showed you the purines the other day, you saw AMP and GMP. I didn't tell you how you got to GTP or ATP. Now we're getting to a pathway where we see UMP. Okay? How do we get to UTP? Well, the way we get to it is by the action of enzymes called kinases. And I think you should know this. Okay? If we go from the monophosphate to the diphosphate, we can call this UMP kinase. Very simple. If we go from the AMP to the ADP, we would say AMP kinase. So each monophosphate has its own kinase, and that kinase converts the monophosphate to the diphosphate. And they're easy to name, so AMP kinase, GMP kinase, CMP kinase, TMP kinase, etc. Now, what happens when they get to the diphosphate is much simpler. One enzyme does all of them. You can take any diphosphate and convert it to the triphosphate. The enzyme is called nucleotide kinase. That's really not what anybody except this book calls it. We will call it NDPK. NDPK. That stands for nucleoside diphosphokinases. You'll probably call it NDPK, and that's fine. All right? Now, I want to underline that. NDPK takes any diphosphate and makes it a triphosphate. It uses energy from ATP to do so. This is true of the deoxy sugars as well. So if I have DCDP, I can make DCTP using NDPK. So we're clear on that? The monophosphates have their own name according to the monophosphate. All of the diphosphates get converted to the triphosphates using NDPK, the same enzyme. Okay? Yes, sir? Is what just wrong? They're using it, well, they're using the same name for the two, and it's not. That's correct. Yeah. This is a sloppy name. In fact, this really should say X kinase, where X is UMP. So that's the problem. Yes, sir?
So you said for each diphosphate, so it could be any of the diphosphates, like it could even be ATP?
ADP, absolutely. Yeah.
So would the ADP just go?
That would just be a frustrating reaction if it did ATP. But it could, yes. You take one ATP, you make one ATP, you start with one ATP, you make one ATP. I mean, so, yeah. But yeah, it'll do it. Okay. That's good. Let us go, oh, sorry, didn't mean to do that. Let us go to, we talked about regulation there. Catabolism, we won't talk about catabolism of the pyrimidines. And the reason we won't talk about the catabolism of pyrimidines is it doesn't really have significant health considerations for our purposes. So we'll leave the catabolism of the pyrimidines out of this. I do want to talk, however, about how we make deoxyribonucleotides. Deoxyribonucleotides are made from the ribonucleotides. Now, the deoxyribonucleotides are converted, the ribonucleotides are converted into deoxyribonucleotides by an enzyme called ribonucleotide reductase. And I'll give you a minute to write that. Then I'll give you an abbreviation for it. Ribonucleotide reductase. A lot of people call it RNR, capital R, lowercase n, capital R, RNR. Now, it